All right, welcome everybody. So my name is Eldon Christensen.
And my name is Mallikarjun.
We're PMs in the high availability storage team in the Windows Server division. And so today we're going to be talking to you about kind of all the new enhancements that are coming for server clustering and hyper-converged, storage spaces direct that are kind of coming, and you'll see in the Windows Insider preview builds and kind of what's coming down the road. All right. So, and feel free to ask questions. I know this is a big room. This is kind of bigger. I kind of did a selfie on you saw before. This is kind of a bigger room than I was expecting. And everybody's a little lopsided. I feel like the ship's going to kind of tilt over. But I like questions. So I like questions during my presentation. It's a bit of a big room, so I don't know how it's going to work. Usually I like that to be interactive and dynamic and talk about what you want to hear about. So if we can try asking questions as we go, and we'll see how it works. And if it doesn't work, I'll adjust on the fly. So we're coming off the Windows Server 2016 release, and we had a big release, right? So we made the biggest bet we really made in 2016 is around delivering hyper-converged, and the foundation of that is really storage spaces direct. And for me, it's kind of a dream, the realization of about 5 years, actually, if I take it back all the way, about 12 years ago when I kind of joined the high availability team and joined the failover clustering team and the development team. I had this kind of dream and vision around having a cluster with no shared storage and really just using the internal local drive. So for me, this is kind of this realization of like a 12-year dream and this giant journey I've been on and just what it took to finally get here in about 5 years of kind of hard development work before we brought this product into market. So it's a big deal. You're going to hear me talk a lot about that during this session. I'm also going to talk about some of the other things we just did in the failover clustering features, high availability, and some of the things in here broadly apply. I'll talk about in the context of hyper-converged, but it also broadly applies to many scenarios, whether it be SQL, file servers, scale-out file servers, and other high availability needs, whether you want to do SAP or whatever, third-party internal apps you might have. And another big realization that came in Windows Server 2016 was that when it came to like stretch clusters, I never had a holistic story. I would say, yeah, absolutely clustering supports stretch clusters. But then when it came to time for like, well, what do I use to replicate the data? I'd just be like, blah, 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 blah. Let's call somebody else, and hopefully they have good guidance for you, and I hope it works well, and best of luck to you. Good luck on your journey. And that wasn't a good answer. I never felt good about it. So what's so exciting about what's in Server 2016 is that we have Storage Replica. And Storage Replica finally brings an end-to-end solution around having a stretch cluster where we can actually replicate the data, have completely automatic failover for not only HA but also for DR. We brought all other features such as storage resiliency and making the system more resilient. We brought in some storage quads. And ultimately, you know, I'm talking about storage spaces direct, but we really embrace choice and your choice. So if you want to use a SAN, we work great with SANs. We've worked great with SANs for 20 years. You want to use NAS-based storage? Absolutely, we support NAS-based storage. You want to run Hyper-V over SMB against the NAS device, whether it be ours, scale file server, third party. You want to do SQL over SMB, Hyper-V over SMB, we support it. And so ultimately, we embrace choice. And that's what S2D and hyperconverged is really about, is about embracing choice and giving you a choice and another alternative in how you want to do your storage in a low-cost way. So I'm just going to do kind of an interesting I just want to talk a little bit about S2D and kind of some of the flexibility and scenarios you can actually deploy it on. And it actually gives us some interesting differentiation. So you may go look at other hyperconverged solutions out there, and what I want to do is just peel that back for a second. So first off, if you just take storage spaces direct and you drop VMs on top of it, it kind of gets this cool, sexy name, right? It's called hyper-converged, right? Everybody's talking about it. Everybody's talking about it. And that's one of the really empowering scenarios in Server 2016. But this is general purpose infrastructure that you can do many things with in Windows Server. So you can put a scale-out file server on top of it, and now you have a NAS device. And then you can run whatever you want against it. You're going to run Hyper-V over SMB. You want to run SQL over SMB. You want to run another app or a workload against it, you now have a NAS device, low cost with internal storage. You can also run apps on it directly. I don't know if anybody actually know that you can run SQL directly on Spaces Direct. Why would you want to do this? Well, here's the real interesting thing. So Spaces Direct can take an NVMe device and make a shared NVMe fabric out of it. So you can put, I don't know if you've seen some of the performance numbers we put up, but we can do millions and millions of IOPS It's crazy. Incredible performance. And so what you can do is you can put SQL Server on top of Spaces Direct, and the real interesting scenario is that you can create an NVMe fabric, and then you can get incredible performance. So you can put apps on there. You get another app internal you want to put on there, you can do that. And it just appears as a CSV volume. So there's nothing special or different, and all the knowledge you knew applies. You can also put it inside a VM. So let's say you want to deploy an Azure IaaS VM. There's no concept of shared storage. And let's say you want to achieve application high availability, that you want to like deploy VMs across fault domains, and you want to be able to fail over your apps from one VM to another one in the event of downtime of a fault domain, whether it goes down for maintenance. You can do that. And actually, because it just takes those virtual drives, and that can be inside of Hyper-V, that can be on top of Azure, that can be on top of AWS, that could be on top of VMware. We've even been talking, working with Google development. There's one thing we're sorting out, they're coming with it soon, but you can even do it on top of GCE. So we started some good things with 2016, and as we looked to the future and where we wanted to go, we wanted to really listen and learn. So we released a V1 product a year ago with Spaces Direct. And so we kind of had a couple things we need to do around, we needed to have some table stakes. It's like a car needs a cup holder and people just expect it. People expect good management. You expect good management. You expect a good management story. And that's just table stakes, and you got to have it. And our story, you know, getting up here and we do all our demos in PowerShell, I don't know that that's a great management experience. It's a great automation experience, but it's maybe not a great for the IT generalist, for your junior admins out in the field, in the remote branch offices, and they need something simple. PowerShell just doesn't work so well for them. So we wanted to simplify the management story. It's just table stakes. We also wanted to know that we need to have differentiators. For example, we know that we are the fastest hyper-converged solution on the market, but that wasn't enough. We didn't want to just kick back and relax and go, yay, us. So we wanted to push the envelope and see what we can do even further. All right, so with that, let's talk about some of the hyper-converged infrastructure futures. And again, these are all things you can go find in the insiders build. So the first thing, one of the gaps that was missing in our hyper-converged story was around data deduplication. So running dedupe, so we support dedupe with REFS, but we didn't support, we supported dedupe with NTFS, but we didn't support dedupe with REFS. And REFS is the mainstream file system that we recommend with all of our S2D deployments. So that was a huge innovation that we needed to deliver dedupe. And so we're actually doing dedupe with compression. So what we do is we'll dedupe the volume, and then we'll actually do, and then on the chunk store, we'll do compression. So it's actually kind of the best of both worlds of deduplication and compression all wrapped into a single solution. We also integrated it. So like with the mirror accelerated parity volume, so mirror accelerated parity is that we're doing writes to a mirror partition, and then we're later destaging down to a parity partition. That gives us really fast I/O on writes, and it gives us the efficiency of parity with having to being able to push that parity calculation to be not in the hot I/O path. And so what we did is that we did some optimization so that when we do the writes and then we go to destage, that's when we go to dedupe. So then we don't have to, when we're doing that data rotation, we only have to write the data once, opposed to we didn't want to have to write the data once and then dedupe it and write it again. So here's kind of what, if we just kind of drew a diagram and said, hey, here's what it would look like with a dedupe without dedupe. It's a whole lot of servers you need for that capacity, and here's with dedupe. So let's take a look at it. So here I'm just going to show you a couple volumes and what it looks like for dedupe. My voice holds out on me. So here you can see I've got two volumes. One says one with deduplication, one says without deduplication. Both REFS volumes, both three-way mirrors. What we did is we created two volumes exactly the same size, put a whole bunch of data on it, copied and pasted the data from one volume to the other volume. And you can see that that one volume is 92% full, exactly the same volume, exactly the same data. The only difference between them is that one turned on dedupe, one didn't. Here I'm showing you our new Honolulu UI, and you can see that we're giving you a nice alert saying, hey, your volume is pretty full. You might want to go do something about this. So now if I go look at my other volume, oh, excuse me, you can see it's only 5% full. And in here we give you capabilities to resize the volume, take it offline. You can see the path that it is within the CSV volume. You get details about it, whether it's a three-way mirror, and here you can see it's only 5% full. Now if we go to PowerShell and just see what that looks like, so if you, just so there's no like, what is the GUI showing you, we can actually go look and see that we're getting a 94% saving on the volume. Again, that's the exact same volume, just copy and paste the data, turn down dedupe on one, and then not on the other. So with that, I showed you a little bit of the UI already. So we needed to, I talked about simplify the management story. So when we shipped Windows Server 2016, we have a bit of a fragmented story. We got a really amazing automation story with PowerShell, but that doesn't help the IT generalist. If you, for the inbox tools, one minute you're in Hyper-V Manager, the next minute you're in Failover Cluster Manager, and you're jumping around between these different tools to do things. Very disjointed experience. We have System Center. It delivers a great experience, but we got a lot of people who don't use System Center. So we have System Center for kind of the higher end enterprise admins, and we needed something in the middle. And so we really want to simplify that story. So let me show you some about this new UI I showed you a little bit about. So if we go in to go manage our cluster, so this is a hyper-converged cluster, the first thing you'll see here is that you're getting alerts. So these, remember I was showing you those volumes were almost full, so here we're getting alerts, getting them bubbled up in a dashboard about those alerts. The next thing you're going to see is you have nice performance metrics and graphs going on about the performance of the system. So you can see its IOPS and its latency and its throughput on what's going on with the system. Now the next interesting thing is I scroll to the right here, and you look at kind of, you get a view by hour, day, week, month. We actually are retaining history. So we have a database, and we are retaining the performance data in a database within the cluster database so that we can go back in time. So whenever somebody walks up and they say, hey, the server seems to be running slower today than it was last week, and you're like, well, how fast was it running last week? Now you will be able to go back and have that historical view of what it looked like from a performance perspective. We'll also give you global views across the entire cluster from, hey, what's the CPU usage, the memory usage, and the storage usage to get this nice simple views and a holistic view without having to go, oh, what's the memory? You got to log into one server, what's the memory usage? Oh, I'm going to go log into another one, what's the memory usage? We're going to give you a holistic view. You can see the servers, you can see the virtual machines that are running. You can see this one's got some VMs that are running, some are paused, some that are off. And then I can go look at my volume and say, hey, I got some of the critical alerts going on here. You can see I got 12 volumes across all the servers. So then you can drill into the different volumes, and you get this global view, right? So you can see, hey, what's the status of them? Are okay? You got some warnings. We see the resiliency settings. That's normally only exposed through PowerShell today. You can see you can click on the volumes and go in. You can see the capacity and what they're used for. You can see the file system. You can see the size used and free. And just the path to the volume there. And then actions, you can conduct them against them in here directly within the UI. All right. So in Windows Server 2016, we support, you can use HDDs, nice slow spinning Rust. You can use SSD drives, and you can use NVMe. One of the things that we wanted to add in pushing the envelope and embracing new hardware support and really unlocking some of the performance characteristics is really unlocking, either way you want to call it, storage class memory or persistent memory. Actually, I didn't have up my slide. I have a split of both. I just realized my title says persistent memory, and the little thing on it says storage class memory. So I missed one thing when updating it. And so that's really help unlocking the next kind of level of performance. And what does that do? So if you look at kind of the access time associated with persistent memory, or storage class memory, what do you want to call it, it's radically faster. So there on the bottom bar, you can see your traditional spinning Rust, your legacy devices that you've known for the last bazillion years. You got your SSD devices and then storage class memory, and then what that compares to with DRAM. So you're going to get a really reduced latency and overhead associated with using persistent memory. And that's something we support looking forward. And it's in the preview builds. I think we're actually doing some, there's actually some demos that are being done on the floor with some of the vendors. So you can actually go see this out on the expo floor. So to empower that, so you got to think about an I/O. So if we are unlocking this new class of hardware device that gives this insanely fast latency to the local device, you got to remember with a hyper-converged solution with S2D, remember you're writing data here, you're also writing data over the network to here, and you're also writing data to the network over here. So it didn't make any sense to have these incredibly, unlock the power of these incredibly fast devices local, when then all of a sudden you have this bottleneck between the network. So we did a bunch of enhancements in SMB. SMB is the protocol transport that we use to transport data between the nodes. So we did further even enhancements in SMB to really reduce that latency so that we can unlock the power of persistent memory. Other performance enhancements you're going to see is around, so we have great, and when you see we do our hero numbers with S2D today, it's really primarily with Mir. Mir delivers incredible performance. And with parity, you get efficiency. And we wanted to deliver efficiency and performance. And so that's what we're unlocking now as we look forward into the insider builds, is that we've really moved the bar on parity up to be much closer to what it is with Mir. So that's going to enable you to have performance and efficiency. So now let me talk about one of the kind of hidden gems that you should know about. And this doesn't matter whether we're talking S2D or we're talking with your SANs today. So there's a feature in Box called cluster shared volumes. Everybody know about cluster shared volumes? CSV cache. CSV cache, everybody knows CSV cache? I got like most hands, I don't have enough hands. Okay, so CSV cache is a mechanism of allocating memory to be, so let's talk about all Hyper-VIO. All Hyper-VIO is unbuffered right through I/O. So what the CSV cache is, it is a read-only cache that unlocks servicing reads from memory. So you can increase the performance of your virtual machines, especially for VDI scenarios. So if you don't turn on the CSV cache today, you should go home and do it. If there's just like one thing with everybody with your Hyper-V deployments on 2012, 2012 R2, 2016, 2008 R2 even, the CSV cache is in there. Go home, turn on the CSV cache, set it to like a gig, and that's actually what we've done now in the insider builds, is that we turned it on by default, and we just picked the number and went with it. On your scale-up file server deployments, you're probably going to want to go bigger. So another thing we did as we look into enhancements in listening and learning, I just view this as the listening and learning, is that S2D is really good when drives work awesome, and we are really good when drives don't work at all. Like when they're dead and they're not working, we built all this logic into Windows Server 2016 called the health service. And the health service detects when drives fail, it automatically removes them. You can walk out and pull out the old one, push in the new one. We will auto-rebuild and pull it into the pool and do everything for you. All that was really hard in 2012 and 2012 R2 with spaces. And we introduced this health service to really solve this problem. And the health service is awesome when drives don't work at all. But we had a lot of problems in the middle, where drives kind of start working and they're not sort of working, and they're being flaky. And so one of the things we wanted to do was introduce logic to detect when drives start, and really kind of we're evolving into this, I'll call it machine learning. Maybe I'll use that loosely, but we're really trying to learn about when the drives are failing and trying to be predictive, and that's where we're kind of, just as a future thinking, where we're trying to go. We really want to get into kind of machine learning about when we predictive failures of when the drives are going to fail, and we don't want to just call you and throw an alert when the drive is dead and you need to quickly pick up the phone and call someone and rush them out with a new hard drive. We want to try to be predictive and give you alerting so that you can plan ahead and you go, I need to order a new drive. I'm on the call, of course, I'll worry about when I get back, maybe on Monday, and you don't need to, and really get ahead of the game. And so this is our first step in that journey, I will call it. Another thing we've introduced in looking forward is around increasing the resiliency. So today, when you create a volume, I don't know if anybody knows from the trivia, one of the trivia questions was like, oh, if you lose 2 nodes in a 4-node, how many nodes can you be resilient to a failure of, or how many faults can you be resilient to? And the answer is 2. And I had this slide that was like, oh, if you have a 12-node S2D system, I remember that, and it's kind of comical. And you say, if I lose 2 nodes, the whole thing goes down. Well, why is that? Let's talk about it, and what are we doing about it? So by default, when you create a volume, it is spanned across all the nodes, and that gives us great parallelization across the set of nodes. But it introduced some caveats with that I can be resilient to 2 fault domain losses. So I can lose a drive and a disk within a data set, or 2 nodes within a data set. But if I lose that 3rd node, then all my volumes go down. So if I kind of look at this scenario, I have 3 volumes, I have 5 nodes, 3 of my nodes go down, and now all of my volumes are offline, all of my VMs are down, none of my clients are accessible. So we want to think about how could we mitigate and scope that. So what we've introduced is the ability to scope the space to a set of nodes, and what that will do is in the event of the loss of multiple fault domains, it will mitigate the impact that it has to the business, so loosely said. So if I look at this scenario, so here I've got those same 3 volumes, but now I'm just scoping them to within, here you can say the first one within 3 nodes, and then the next one within 3, and the last one with the last 3. So if I lose those last 3 nodes, now that volume is down, but only that volume, and the other 2 are up. So in the first scenario, all of my VMs would have been down. In this case, only 1/3 of my VMs are down. So we're trying to work on how can we mitigate the large number of failures within the system, the overall impact to the business, and how can we try to keep as much up and running as we can. And then just kind of building on that, we really wanted to work on diagnosability and how we can and make the system more diagnosable. More diagnosable. There we go, I said it right. So we're extending the health service. So the health service really started out around storage, and we're extending it into compute. And so really detecting faults of nodes and cluster failures, and then bubbling those up through the health service and giving this unified alerting within them. We're building in a bunch of recovery tools with REFS. We're improving just logging in general. So the setup logging, when you're enabling S2D, if you run into faults, it used to be this kind of, you just got like PowerShell output. We're having nice HTML logs that are nice, clear. We're working on the eventing and the error handling and the messaging to make it more intuitive when things go wrong and what you need to do about it. We're also in cluster networking, and this applies, the cluster networking enhancements apply to S2D in all cluster scenarios. We introduced a bunch of self-healing logic around detecting the routes between the nodes and when routes go down or are inaccessible, and then rebuilding those routes and having some self-healing logic. So that's going to bring value to all your cluster scenarios, whether it be with your traditional SQL or your Hyper-V or your scale file servers. And then we've just added, we're learning, we're looking at our support data, we're seeing what are people tripping over, and we're adding tests into our validate that will proactively detect hardware misconfigurations, incompatible systems, and then alerting those up. And you'll see those come. So in those monthly updates, we are pushing out updates into those. So in the storage replica, I talked about at the beginning, was one of the great new features that was introduced in 2016, right? So now we have a volume block level async or asynchronous replication solution in box, so you can do disaster recovery and you can do stretch clustering. So one of the things that they've added in forward-looking is the ability to do test failover. So you can mount the replica on the other side in a read-write mode, and so then you can, if you want to test and make sure things work, if you want to, I don't know, do a backup off of it, you just want to snap another copy of it, you can do that now. The other thing that's been done is to try to simplify the management experience. So we've integrated storage replica into SME, into the server management experience, so it will be easier to manage now as well. So as we look at running SQL, so I talked about that at the beginning, that you can even run SQL on top of S2D. One of the things that's missing is people say, hey, I want to run SQL on top of S2D, and this is S2D or SANS, is that one of the things that you can't do is the DTC, people who like DTC, excuse me, with SQL and have dependencies on it with their apps, you can't use it on a cluster shared volume. So what we've done is the DTC team has done work to support cluster shared volumes. That unlocks running SQL on CSV for whether it be SAN scenarios, but most importantly is running it on top of S2D. So if you want to deploy SQL on top of S2D and you have dependencies on DTC, that wouldn't work with CSV in the past, and now it does. We also did a bunch of security enhancements forward-looking. So one of the things we did is we completely switched over the cluster inter-node communication to do all SMB traffic now uses certificates. So in the past, so here's the biggest one, is clustering had dependencies on NTLM. So if you wanted to deploy clusters and you disabled NTLM, if you had a security admin who declared, thou shalt disable NTLM, that's one thing you couldn't do with your clusters. And that was an issue we had some customers with some very high security needs. who were very security sensitive, and so you couldn't disable NTLM. Now, with the new current builds, you'll be able to disable NTLM. The other thing that we've done is that you can now do encryption of the intra-cluster communication. So there's kind of two forms of SMB communication happening between the nodes in the cluster. So one is that S2D is using SMB as a protocol transport. So any of those IOs that are being written on this node, we're using SMB as a protocol transport and being written to other nodes. So you can use BitLocker to encrypt the data at rest, and you can have security of that data. So it's one thing a lot of people don't know is we actually support BitLocker on S2D volumes in 2016. So you want to use BitLocker, you can do it today. And you can also do SMB encryption. So you'll be able to do encryption of the data at rest with BitLocker and encryption on the wire between the nodes with S2D. Now we're also doing some metadata forwarding at the CSV layer, and the CSV layer applies whether you're doing with a SAN or not. So then you can turn on encryption of that SMB traffic that is happening between the nodes for cluster shared volumes as well. All right, and with that, I'm going to bring up Mallikarjun to talk about cluster sets.
All right. Thanks, Eldon. Hey there. So we have a pretty exciting new technology called cluster sets coming up in the insider builds. You should definitely check it out. And this is really to give you guys an introduction about what is it. First of all, cluster sets, as the name suggests, right? It is take a few clusters, the failover clusters you know and love, and loosely couple them in a way that you allow the fabric to scale out, right? I mean, this is really, when I say scale out, this is really taking the fabric scale out to the next level of scale out, literally to thousands of nodes. That's the design objective, and the loosely coupling is the magic secret sauce there that allows us to go scale it out to this scale. And one of the cool things about this is, hey, you can not only live migrate virtual machines across nodes within a failover cluster, but you can also live migrate VMs across failover clusters, which are all members in the same cluster set, right? As you can see here, I will talk about this componentry at the bottom. That's just to give you a mental view of what I'm talking about, but I have a little bit more detail coming up on all the componentry in the bottom. And when VMs move across clusters, obviously they should be using some storage, and the storage path name should not change when the VM moves from cluster A to cluster B, right? And so we built a new self-managed, dynamically updated namespace that spans all the clusters in a cluster set. We call it CS namespace, the cluster set namespace. And the graphic shows how that all comes together, and I'll give you more detail as well. So that's cluster sets in a nutshell. And then let's talk about why you should care about cluster sets. Well, first of all, cluster sets is all about scale, right? If you really want to scale out your fabric to a very large scale, this is really the answer for you. We talk with a number of customers that have a large number of clusters in their data centers, but typically the cluster set, the individual cluster size that they deploy is very conservative, well below the size of 64 nodes. And they tend to be conservative because there is this notion that, hey, what happens if my software or hardware goes wrong? I really don't want that to be, the blast radius to be very large. So let me build small clusters. So what cluster sets gives you is the best of both worlds, right? You can continue to build small clusters. You can contain the fault boundaries to a smaller footprint, while also stretching out your fabric to a very large scale and derive the benefits of the scale. And I'm going to talk about what specifically they are in a minute. The second thing is, if you looked at Eldon's trivia questions at the beginning of the session, right? One of the questions is, hey, what is our guidance regarding the similarity of all the nodes in a cluster? Generally, our guidance has been, we really want them to be the same because we don't want surprises and workloads failing over across nodes and getting completely different performances and such. With cluster sets, now we are really talking about multiple clusters, right? So these clusters, while the individual clusters may be relatively similar in their composition, the cluster sets, the across member clusters, they could be relatively heterogeneous. It gives you a couple of examples. They could be different at the processor level. They could be different at the networking speeds and the storage, et cetera, et cetera. The other thing is changing the compute to storage ratio. When you're thinking about hyper-converged, right, cluster sets itself, by the way, could be deployed for compute clusters, storage clusters, or hyper-converged. It doesn't really matter, the foundational technology for all kinds of workloads. Now, when you start thinking about hyper-converged, one of the things you typically run into is when you deploy hyper-converged, you're kind of stuck with that compute to storage ratio because you have a certain number of storage capacity and compute capacity in the cluster you deploy. Now here what's going on is it is actually relatively straightforward to change the compute to storage ratio in a hyper-converged cluster set because all you need to do really is add a compute cluster to the mix and there you have changed the compute ratio in the compute weight and the ratio in the overall cluster set. The same thing goes for storage. Now, when we reviewed this feature with some of our service provider customers, they loved this aspect of it, which is with cluster sets, they have now an ability to take a tenant VM or a service, and really they can keep it running through the entire life cycle of the cluster. You can onboard new clusters, you can patch them, you can run through their entire their life, and finally you can say, okay, I'm retiring this cluster. All through that, you don't really have to take down your workloads because workloads are now movable, migratable across member clusters. In the availability sets and fault domains, when you start operating your fabric at scale, you're really thinking about, oh my God, there's really a lot of heterogeneity, there's a large number of nodes. Where's the best place for my workloads? Where do I place them initially and make sure that when one cluster maybe goes down, I don't want to bring down all my service that may have multiple copies in different clusters, right? So it's a complicated math in terms of where you want to place it in a workload when you have multiple clusters and multiple nodes. So what we're doing is Azure has an excellent solution for this. They have the availability sets and fault domains for compute. You can specify a number of fault domains within an availability set, and you target your VM for placement in the availability set, and it gets placed in the right fault domain within that availability set, largely taking all the complexity away from the users. So this is Azure-like semantics in cluster sets now that we are adding, which allows you that fault domain and availability set semantics for the compute as well. How many of you actually use the Azure availability sets? Did anyone use? Okay, a fair number of you have used, which is fantastic. Yeah. So you will appreciate the value it brings to the table. So let's start with a very quick solution view. Cluster set, this big green box. Now I have a few member clusters. These are all individual failover clusters. And by the way, when I say they're clusters, they really are clusters with backwards compatibility. They have the same management plane. The existing WMI APIs don't change. The PowerShell works, and everything you know about failover clusters holds true for the individual member clusters. Now, what is going on is our recommended deployment is that the management plane for the entire cluster set, which we're building a new management plane, a new set of WMI APIs, new set of PowerShell commandlets for the entire cluster set. And our guidance is that the management plane itself should span all the member clusters because you don't really want any one member cluster to be a single point of failure for the entire cluster set, right? So you see that guest cluster there that's spanning the individual member clusters. And and we also have a notion of master and worker. Those master is a resource, a new cluster resource that we added here that basically makes sure that it is the liaison, it's the sort of master coordinator across the entire cluster set that understands the placement, that understands the health about the individual resources running in all member clusters and understands the statistics, etc. And then you have the notion of logical fault domains. Logical fault domains are what I was just speaking to, the Azure-like semantics. And the logical fault domain may be one or more member clusters in a logical fault domain. And the reason you would do that, of course, is to build an availability set around that. And so now you can place your workloads in a specific logical fault domain within that availability set, right? So there are a number of concepts in there. Obviously, we will have documentation for this as well as part of the insider builds. And I think I have a hidden slide as well here that actually basically describes each one of these concepts in text format as well in this deck that you can check out later. So with that, let's look at the demo. I have a cluster set here. First of all, I just want to, let's see, sorry. Okay, so let me just pause that for a second. But did I do that? So what's going on here is that I just want to give you a taste of the functionality of what cluster sets is without really going into the scale aspect of it. I just have 3 member clusters and 1 management cluster here, right? And as you can see here, the management cluster has the scale out master resource. That's the new one that I was just talking about. And the 3 W1, W2, and W0, W1, and W2 are the workers, right? So they are the member clusters, and it has the worker resource in them. Now, let's look at the PowerShell side of it. I'm running on one of the clusters here. Let's see what that is. I think that is the management cluster. So I do a get cluster. This also sort of tells you that the management surface is really the same. So it is running on C1, which is my management cluster, which is the very top one in the left-hand pane. Then I do a get cluster node. Again, it's a legitimate full-blown cluster. It just happens to be the management cluster in this case. And now let me do a get cluster set. And get cluster set is showing me that I have a C1 underscore M, which is the name of the cluster set at the aggregate, right? And then I have a namespace as well that is associated with that. As you can see, that is the new namespace. The one that I'm highlighting is the new unified namespace that spans all the member clusters in the cluster set. Now let's do a get cluster set member just to make sure that it is the same cluster that I'm showing in the left-hand pane in the failover cluster manager. It is the same one. W0, W1, and W2 are the 3 member clusters in that cluster set, right? Now, yeah, it is showing the individual members. I'm just iterating through the cluster nodes within each member cluster. Now I built the cluster. Now I have a virtual machine that I have marked as my cluster set VM. So think of a cluster set VM as a super highly available, if you will, that is actually highly available across member clusters. Now I have it running, and my cluster set VM is running on, I think, node 10 on that. Oh, by the way, this is a nested virtualization. Just to make sure you guys got that right. So my cluster set VM, VM1, is actually a cluster set VM that's running on a VM host, which is VM10. Just to make sure everyone caught that. So I'm running it, like I said, on W2, on node 10. I want to actually now move it to a different cluster altogether, which is my W0 cluster. And then I come back, and the first thing, of course, I do is set my destination to wherever I want to move this to. So I'm changing it to VM3, I guess, VM03. Yeah, that's my new host. Then I set the destination, and basically I kick off the migrate cluster set VM, move cluster set VM commandlet. It's a time-accelerated video. It takes a few minutes, so I jump ahead and I took all that out for you for this demo. So no, that's it. So basically, my VM is supposed to have moved from W2 to W1. Yeah, it is here now on W0, which is good, right? And let's also double confirm that one more time from our PowerShell, right? Yep. As you can see here, now it was at W2, now it is on W0. So just to recap what happened in the demo, right? I have a cluster set with 1 management cluster and 3 member clusters in it. Each cluster has like 3 nodes or so in this particular demo. But we have tested multiple deployments in the labs already that run more than 100 nodes in the cluster set, and we keep increasing that scale every day. Now, what I did is I took 1 VM out of that's running on 1 member cluster and moved it to another member cluster all through my PowerShell, all as while the VM is up and running. And this is the exciting power of what the cluster sets brings to the table to start with. Now, let me wrap up this part of the section with one quick piece of guidance on where you should when you should think about deploying cluster sets as opposed to clusters, right? Because cluster sets is super useful in some cases, and you may not really want the cluster sets because you require another management cluster and some additional infrastructure resources as well going on, like master and guest and all that, master and worker. So let's look at that. So what's going on here is there are really 4 decision criteria at this point for with the insider builds that we recommend. One is if you're really running into hyper-converged scale limitations today, and you really want to or somehow feel constrained by the compute to storage ratios, and then yeah, cluster sets is potentially interesting for you. Heterogeneous servers. Do you really want to deploy heterogeneous servers in your fabric and manage them as you keep adding more and more servers, and let's say the OEM manufacturer is not providing that older generation of servers anymore, you want to add a new generation of servers, this is another good technology to consider. Live migrating VMs across clusters. Well, you may be actually perfectly fine with live migrating within a cluster, and that's good, and then that's not a consideration for you. But if you do really value that, then there is something to think about. Azure-like compute availability is another consideration. If none of these are really super useful or interesting to you right away at the current scale that you're operating your fabric at, then, well, maybe cluster sets isn't really the thing for you, right? Failover cluster would work just fine. If it is interesting, if these things are really drivers for you in going out and really choosing a fabric technology, then cluster sets is probably useful to you. In that case, we strongly encourage you to go embrace insider builds and start testing and giving feedback, and ping myself or Eldon here to work with you to bring up your workloads and clusters, and we would love to do that. With that, I think that's the end of my section. Eldon, you want to come back up?
Thank you, Mallikarjun.
Yep. Sure.
Sorry, can I ask a question?
Yes, sir.
Aha, yes. There's someone mystical that I cannot see.
Here I am.
Where?
On your right.
All right.
Sorry.
Welcome.
So, in the cluster sets, is it possible to migrate across like 2012 R2 cluster to 2016?
Sorry, is it possible to migrate?
If I have one cluster on 2012 R2, like I want to add, I just want to move away from that, or I have something, a 2012 cluster in my environment, and I want to be able to shift that from to 16.
Cluster sets would not be the technology for that. Cluster rolling upgrades would.
Like, is it backwards compatible to?
No, it's a new feature only in 2016, and so it only works with 2016 and forward.
Correct.
But it is something that we're thinking about in the sense of being able to support multiple clustered versions, forward-looking, within the same set.
Right.
Thank you, sir.
Yeah, and then within a cluster, you can do a rolling upgrade. And because you actually asked a question, somebody actually asked a question. Here's a T-shirt.
I'll give that to you.
Now, the funny thing is that I was joking with Mallikarjun. I'm like, we'll throw the T-shirts from the stage. And then I walked in and go, there's like a pit. There's like a mosh pit here. I can't exactly throw the T-shirts. So the room is too big. See, now you rest of you are incentivized. I got more over here. So ask more questions. Let's talk about clustering, more of the cluster stuff. So that's really exciting on the cluster sets. I mean, we're going to achieve hyper-level scale, right? We're talking being able to scale clusters. We've always talked about when we first shipped clustering at NT4, it was 2 nodes, and then Windows 2000, it made it to 4, I think, and then 8 came in there somewhere in Data Center Edition, was it in 2003, and then 64, and now we're going to be able to go to thousands of nodes. So this is kind of exciting. But again, it is, as Mallikarjun tailored, I don't know that everybody needs to rush out and make their clusters all go to thousands of nodes. It depends on what your needs are. So it's cool, but don't always just rush to do the cool. VM start ordering, another feature, another V1 feature introduced in Windows Server 2016 was VM start ordering. And what VM start ordering allowed you to do is to say, hey, I got a multi-tiered application which spans across multiple VMs. I have one VM which is running my SQL database. I had another VM which is running my application which is querying into the SQL database. What we empowered you to do with 2016 was to be able to set a delay, saying, hey, start this one, now wait, and once that one started, start this one. That's what VM start ordering is. Our delay in 2016 was just a timer, so you had to manually take a guess. I don't know, 5 seconds good enough, 10 seconds good enough, 20 seconds. So you just would set it, and you would say, start this VM, wait 20 seconds, then start that VM, or whatever value you picked, and then start that other one. And so that wasn't very, it achieved what it needed to do, but it wasn't very elegant, because you were just guessing. You tried it once, and it took 20 seconds, and the next time maybe it took 23 seconds. So what we've introduced now in the Insider builds is the ability to trigger off the OS heartbeat. So when the OS starts and integrated components within the VM signal down, that tells us that the OS within the VM is booted, and that can be now a trigger to say, aha, the OS within that VM is booted, that's enough of a head start, now go start the next VM in the chain. And then that one will start the boot and give you things. If that's not good enough, let's say you have an app that takes a really long time to start up, you can also do it on triggers on the app. So like when the app throws an event in the event log, when some executable fires up, then go start the next one. And so you can have that level of granularity. So you can do just a hard-coded timer to say wait X seconds, or you can say, hey, and in my mind, I think that's the best answer, is the OS ready, which is saying, hey, the OS, the integrated components within the VM has started. In my mind, that's if the OS is fully up and booted, that's probably good enough, and then you start your next one. So that's a big one. Another thing we've done is we've enlightened clustering to know when it's running on top of Azure. So what we're seeing is that people want to achieve higher levels of availability and higher SLAs than what Azure can deliver them. And so what people are doing, or any public cloud, let me just phrase it that way, but so people want to do is they want to achieve higher levels of availability, so they're actually putting high availability of the applications running inside the IaaS VMs. And so with a lot of now we're seeing clusters running on top of Azure IaaS VMs, we wanted to try to make them smarter. We're taking some steps in that journey, and the first ones we're doing is that we are now aware of when we're running on top of Azure. So we will now query to see if we're running on top of Azure, and then we do some things for it. One of the things we do is that during cluster setup, we will change the way clustering actually does a setup. So if you're familiar with a scale-out file server, the scale-out file server just has a network name resource, and then it doesn't have any IP address resources. It just uses the local IPs. We are using, but a normal cluster name, you have a network name resource and an IP address resource. And when you configure a cluster on top of Azure, there's a burden on you to have to go configure an ILB associated with this, and that's just a giant burden. So what we'll do is that when we detect now that you're deploying a cluster on top of Azure, we will flip the network name resource to be a distributed network name resource, dynamic network name resource. It should be distributed network name resource, I think, for the cluster name. So then we just use the local IPs and we don't use an IP address, and that just saves you from the burden of having to configure all that. So that's just making it simple, or simpler, let me just say that. The other thing that we've done is that we will detect maintenance events. So when Azure is going to do maintenance, when they're going to do VM foo and they're patching the underlying host, and they're going to bounce that host super quick as fast as they can and bring it back up, we will detect that and throw events in the event log. So we'll throw events in the cluster log and the event log saying, hey, this host is about to go for host maintenance. Why is that good for clusters? Well, we're seeing issues sometimes where we're doing intra-node heartbeating, right, of the nodes. And when we detect that a node goes down, we go, oh, and we start failing things over. So now it's much simpler. Before you wouldn't know, hey, why did my VM go down? But now you'll be able to look in the event log and go, you'll be following the cluster log and you'll just be going like, oh, look, Azure host event, node detected down. So it's much easier to troubleshoot those sort of scenarios when Azure brings a host down. The other thing we've done, which actually I forgot to put on my slide, is we modified the heartbeats. So when you deploy on top of Azure, we're going to crank up some of the heartbeat thresholds because we know there's a little more network latency when your cluster is running on top of Azure. So we're just a little more lenient on the heartbeat thresholds. And we want to take it the next step further. So I don't even know if we're talking about this, but things we're thinking about, which aren't in the insider builds yet, but things we're thinking about is how do we take this further? Like, for example, when we detect that a host is about to go down, so Azure throws an event, says, hey, I'm going to reboot this node in 15 minutes to apply a patch. Hey, what if we could do proactive failover? We could go, aha, the VM that this host is running on is about to go down, which means this VM is about to go down. Let's do a proactive failover at the application layer and fail that app over to another VM, which we know is running, in another update domain, so that we know that that thing can go through its update cycle, keep that app running, move it to another VM, and then to try to achieve those higher levels of ability. Again, that's not in the insider builds yet, but that's things where we're thinking on the roadmap of where we're going. All right, so this was my, so what is like the worst, it's like the worst IT admin ask you could get of your clusters today that just makes you want to cringe. For like the last 20 years, what's like the, anybody want to take a guess? What's the thing that like, for your cluster admins, like what's the one thing that some random Yahoo could show up and ask you to do and you just be like, oh man. Do a what? Something migration, I heard something migration? Storage migration, storage migration. We need to talk. All right, I wouldn't have said storage migration.
Update the cluster.
What?
Update the cluster.
Update the cluster. Well, you got cluster where, okay. The patching model totally changed in 2016. Cumulative updates, no more 1,000 little updates. Got clusterware updating. Hopefully we're making traction there. All right, since nobody's even guessing, hey, let's move this thing to another domain. That just sounds like a great idea. Anybody have to do that? Anybody just have something up and go, dude, we're just gonna move them all to another domain. That's a great idea. What does that involve? Start over. Yep, there is no way to move a cluster from one domain to another. When you show up and want to do that, you're basically saying, okay, we're going to destroy the entire cluster, rebuild the whole, move it over and rebuild the whole thing from scratch. And that's because we have all this tight AD integration, and so there's really no way to move it from one domain to another one. And that is a giant, that has probably been the worst admin action you've ever had to perform for a cluster. There's no other action I can think of where you have to start over. My answer is literally, yep, start over, man. That's your answer. That's, anybody, yes, no? All right, so we're working on it. That's the thing that hopefully makes you feel better. So now we have the ability to move clusters from one domain to another one. In fact, you can dynamically change the membership of the cluster as we go. So you can have a cluster which is up and running, which is in the domain, which is domain joined. You have network name resources, they have computer objects, CNOs, VCOs, all that stuff. All that interconnection and intertwined with AD. You run a commandlet and you basically downgrade and you say, okay, I want to break all my connections with AD and I just want to run, I want to take my network name resources, disable all the computer objects, break all the dependencies and be able to run without it. And then you can change the host, and you can change the host and you can change from a domain joined to workgroup. You can change them from one workgroup to another domain. And then when you get them in the new domain, you can run another command that which says, hey, go recreate all those computer objects, what happens during create cluster, reestablish all the AD dependencies with CNOs and VCOs and all that stuff because I want to be able to do curb authentication against my names. So you can now dynamically change on the fly the cluster. So one thing is when the person shows up and says, hey man, let's move it to another domain. Now you don't have to freak out. Another thing which is really powerful is in the deployment scenarios. So before, if you were in your lab, in your central headquarters, and you're setting up some systems and you want to deploy them out to your remote branch office, but that branch office happens to be in another domain, you couldn't do that. And so what you'd have to do is you'd have to write all these scripts to basically send it out, and then you have some junior admin who's trying to run all these scripts to go get all these things working and fired up and created and everything set up. Now you'll be able to build the cluster in your lab, in your primary data center. Then what you can do is then detach all the AD objects, make it a workgroup cluster, ship it off to the site, and then say, hey man, all you got to do is you run this commandlet, which is going to domain join all the nodes. Then you run this other commandlet, which is going to then join the cluster into it, create all the VCOs and CNOs, and then everything is going to be all configured for you. So that should helpfully simplify pre-configured solutions that you build in your primary data center, then ship out. So this question is, I don't believe you, would that be safe on my production cluster? You know, there's fun things you can do in the middle of the afternoon, you know. I just like to do live migrations randomly, you know, see if people notice. But it's yes, our goal is that it will be safe to do on a production cluster. Yes, that is my promise.
So you can let us know when it's safe?
Yes, I'll let you know when it's safe. Again, it's still an insider preview, so I get to claim it's not safe quite yet. Yeah. So the next question was, hey, what about those clusters running in Azure and being Azure AD joined? Yeah, so it's a good question. We're not, so you're ahead of me. So the question was, hey, the client guys are off allowing you to do Azure AD join. Can I do that with my cluster yet? The answer is not yet. Haven't thought about it, I'll be honest, all that much. But a good question and something we need to get on our radar. And you both actually ask questions. You both get t-shirts. All right, here you go. You're close enough. I can actually get it to you. And here's another one. Almost. Almost. I need like a gun, a shooter. All right, where was I? So that's kind of the summary of everything that I got here. So so again, some big stuff coming for hyper-converged. We got dedupe. We have the management story, simplicity, and dedupe getting up to 95%. You saw I did the demo. We got 94% on a real volume. That was like one volume, another volume, copy the data, enable, don't enable, 94% saving efficiency. It's crazy. The management story, right? We've had this fractured management story. And with storage, with Windows Server 2016, you can get the lowest CapEx solution for doing hyper-converged. It's the cheapest. It's in the data center. It's everything you need to be able to do a hyper-converged system is in Windows Server Data Center Edition. There is no additional cost. There is no additional tax. So you get the host OS, you get your hypervisor, you get all your high availability software, you get your hyper-converged infrastructure, you get all your client licenses running on top of it, one price. No add-ons, no monkey business. And so that's the lowest CapEx. We want to give the lowest OpEx as well. And that's what we're doing with our new management story that we're coming with, is really about simplifying the management story and not only delivering lowest CapEx, but also lowest OpEx, excuse me. Performance, we're already industry leading. We're like 3x, I'll say that boldly, than anybody who claims to be number 2. Like people actually, it's funny, the OEMs, if you go talk to them, I like to say on stage or boldly that I'm 3x faster than this next fastest guy. And the OEMs like whisper up to me and they go, Eldon, like I actually had a vendor say this, you're totally wrong, you are not 3x faster. You're actually much, much faster. So that's a conservative statement is 3x. So that's my conservative on stage statement I feel comfortable with. Hyperscale, we're going to go crazy level scale with cluster sets. So we're going to be able to achieve for you that need that level of hyperscale, who in like what we're doing with Azure Stack and being able to get that on-site region level sort of scale. That's what we're doing with cluster sets. Storage replica, a bunch of enhancements really exciting around enabling test failure and SME. Security, again, you can do NTLM lists. We're doing encryption on SMB. You can do BitLocker on S2D. We're really detecting on top of Azure. And then again, we're trying to push the needle on diagnosability and making reliability. And I talked about like marginal drive handling and being resilient to that. All right, so try out the insider builds, join the tech community. And we have a few more minutes, so I can take more questions. We got about 50. So the question was, are 2-node clusters supported with S2D, you're asking? Yes, so 2-node is supported with S2D, absolutely. And it's very lightweight. All you need is a witness, and you can support either a cloud witness or a file share witness. So it's not like some of the other guys who you got to have like a 3rd node in membership and some VMs in some magical place. You can just do 2 physical servers, file share witness. Actually, the simplest is a cloud witness. I do that. Just uses Azure Blob Storage. It uses it so lightly that you can't even, it's nearly free. Or what? So the question was, so for a 2-node, do I have to have NVMe? No, you could do any of the combinations. So yeah, there's no dependencies with a 2-node. You could do HDDs with SSDs. You could do all SSDs, NVMe with SSDs. Yeah. Good question. Oh, I still have more t-shirts. Aha. I'm terrible. All right, yeah. You want to answer? Sorry, so Melkaj, the question was cluster sets. Can I do stretch DR sort of stuff with cluster sets?
So from a design perspective, there is nothing that blocks that. But from a early, in the insiders build so far is only tested for a single site. So I don't know what's the, yeah, so yes. But that's definitely one of the scenarios we have in our design scope.
It's lost somewhere in the crowd.
Sorry.
You had mentioned that the application to your left, you had
this is so bizarre.
that your 3 VMs that run the application that it'll start up in order. My question is, if all three VMs are running and you reboot that SQL server, will the other two reboot with it? Can it watch for that SQL server to reboot and then turn around and reboot the web and app server as well?
Okay, so let's talk about, oh, there's your t-shirt while we're throwing. So when you're doing VM start ordering, what you can do is you can define, so you define groupings, so groupings of groups. And so basically you say, hey, these groups are within a group, and then you can do, and then within those you define policies. So you can say, hey, wait, so let's say you had 5 database servers. You can say, hey, wait for all 5 database servers to start, wait for 3 of the 5 to start, wait for majority to start, or 1 of the 5 to start before I start the next tier. So you can define what defines majority before I start the next tier, and then you can define the timing between the next tier. And then also on like failover and start over, whenever there's a failover, so let's say we do a failover, they will then honor those as well. So it will honor those on like failover and startup as well. Good question.
Will storage replica work across a WAN?
So the question was, yeah, storage replica, yeah, absolutely. So storage replica supports either sync or async replication, and both is supported within a stretch cluster. So you can do, for planned failover, then with async, of course, with async and planned failover, there's no downtime, or RPO, I might give my RPO and RTO. So your RPO would be 0 and your RTO would be 0. So there's no data loss on that. But if you have a asynchronous replication and then you have a hard unplanned outage, there can be some minor data loss depending on how far behind the async is. Did that answer your question? Yeah. Yeah, okay. Yeah.
Yeah, we always talked about Windows Server Insider. Is any of these features in version 17.09 already available, or everything in Windows Insider?
Yeah, so great question. All the features here are available in the Insider's builds. They're not in 17.09.
Okay.
It's a question regarding, okay.
Yeah, good question. So the question was, hey, what's up with this 1709 thing, and what about R2s and stuff like that? So let me just talk about it. So first off, we are now trying to align server with client in the sense of what we have our semi-annual release cadence, what we call SAC releases. And so SAC releases happen every 6 months, and they are supported for 18 months. So one of the things is that if you get on a SAC release is that it's only supported for 18 months. So you have to upgrade every 6 to 18 months because we pump one out every 6 months, and it's about just having these little increments. Yeah, so, and then we'll have LTSC releases. So LTSC, from a server perspective, is everything you've known for the last 20 years. Server 2016, 2012 R2, 2012, 2008 R2, 2008, those are LTSC. Those are long-term servicing channel. Yes, long-term servicing channel, yes. Long-term servicing channel, which means they're supported for 5 plus 5, and then if you get premium assurance, you can get 6 more on top of it. So you get 5 of mainstream support, 5 of extended support, and then you can buy premium assurance and get 6 more years of support if you want to. And we will continue to release those. We released, from a timeline perspective, that will be your next question, we released Windows Server 2016 in October of 16, and you should expect that with our software assurance, we have promises to make it within 3 years, that within 3 years we will release another LTSC. So you should expect between October of 16 and that would be October of 19, somewhere in there will be another LTSC.
So and that would be like Windows Server 2019 would be like just Windows Server 19.
Yeah, right. Okay, so now it's around the branding. So we will brand, so like the LTSCs are branded, you'll see like Windows Server 2016 was an LTSC and we brand it that way. I don't know, Windows Server 2019 will probably have that sort of branding on the LTSCs. I don't know what it'll be, so don't quote me on any of this. And then with the SAC releases, we have changed the branding. And so what you see is it's just Windows Server, and then we add the version, and then it's basically month year. So that means it's 1709 as it released in 17 in September, technically. So that's all that means. The 1709 is month year.
Do you know what the time frame for the Azure releases for the templates are for the S2D?
Oh, great question. So Azure templates for S2D are actually out there today. There's a blog published, and we got a bunch of templates, and it will do scale-out file servers. It will configure S2D for you. There's 3 or 4 of them out there. Yeah.
cluster set, is it available also with Windows Server 16, so the LTSB, or only in the insider build?
You want to take that one, Malcolm?
Sorry,
The cluster set functionality, is it also available in Windows Server 16 or only in the insider build?
Yes, it's only available with the insider builds.
Okay.
It's not in 17 or 9 either, as Eldon just said. Yeah.
Thank you.
Yeah, some questions over here.
Was there a question there, or?
Oh, sorry. Yeah. Have a relatively small environment, more like a branch type scenario. Currently have Windows Server 2012 R2 clustered with fiber shared storage on the back end. So I think I know the answer to the first part of the question. Just with those two existing servers, they are compatible with Server 2016. Could we, when we chuck out the fiber, light up currently several terabytes of dark local storage with storage spaces direct, and at the same time run Hyper-V on that same cluster, or is that not supported?
So,
in other words, can we set up VM and VM cluster and the storage spaces direct on just 2 nodes?
So my answer is yes and no. So the answer is yes, absolutely. You can deploy with 2 nodes, with just those local drives, create a highly available solution, run the VMs on top of it, have a hyper-converged system using those low-cost internal drives, get rid of that expensive SAN, absolutely. Now, can you use your existing servers that you already have that are already deployed? That's where I start to kind of say I get a little wishy-washy. So all the vendors have solutions that are available. So I don't care who your vendor of choice is, whether it's Lenovo or Dell or HPE, they all have storage spaces direct solutions available. And I would recommend that you get one of those. So I would get a pre-validated solution and not just try to put something together out of what you have. But the answer is you can absolutely do it when you go to make that next hardware acquisition.
Okay, so just JBOD drives wouldn't be, I mean, you would want something that's validated.
Yeah, I would want something that's validated. Now, could you have people done it? Yes. Might it work? Maybe. I'm just trying to guide you down what I think will be the most successful path.
Okay, thanks.
Yeah. Yeah, go ahead.
When you do the deployment of an all-flash cluster with read-intensive SSDs, is there any way to monitor the durability of the drives, how worn down the drives are?
So yeah, So we have a blog that we recently published that talks about kind of the drive write per day requirements and endurance requirements with S2D. So we have a good blog that talks about all the drive write per day requirements. Do you have a good mechanism? So the short answer, I think, is no. I know we're trying to
PowerShell today, right?
Will PowerShell show you the?
Yeah, I think it.
You think it will show?
I think.
So Malakarjan thinks you can see the endurance through PowerShell?
Yeah, I mean, but I mean, Eldon is right. The blog post that he refers to does have the PowerShell as well cited in there. Depends on if the SSD is actually reporting those back to the PowerShell or not.
Yeah, that's the sticky point. Is some devices report correctly and some don't. There's kind of a lack of standardization across the drives vendors right now that we're kind of struggling with a little bit. So that's why I'm a little. I hope it works. So.
Thanks.
Yeah, but if you want Eldon C so if you want to shoot me a mail, eldonc@microsoft.com, and I can shoot you the blog link. So.
Thank you.
Yeah. Okay, one last question. All right.
What kind of performance impact are you seeing from dedupe?
It depends on the workload. So right now, dedupe runs on if you run, so we're actually, the way we do dedupe on an RFS volume is that we actually do it on rotation. So what we do is that you're doing all your writes to the well, actually it lands on the caching devices, it will land on the mirror partition on a mirror accelerated parity, and then what we're doing is that we're then, as we rotate the data, that's when we're doing it. So we have the least amount of impact when we're rotating the data real time as we're going between tiers. As the data is being written and the volumes will fill up, and then as data cools, then we'll rotate it. We'll actually compact it into slabs, and then we'll rotate the slabs out.
You don't have any rotation because you have one tier.
If you don't have, you're saying if you have a flat design. If you have a flat design, then it actually it runs it on a periodic basis on when it does the dedupe. So you have a job which you can configure. I think it runs every 24 hours by default. And then it will run as a maintenance task. So it kicks off every 24 hours at like 3 o'clock in the morning. And then it goes and dedupes the volume. So it has the least amount of impact. But you can tune when it actually runs.
Thank you.
Yeah, go ahead.
Eldon, is dedupe supported for more than just VDI and backup VHDX workloads now?
Yes. Yep. That's a mainstream scenario now. So the question was, are there any file size limitations? The answer is yes.
I think it is 64 terabyte volumes, I think now, right? There may be.
Yeah, and there's a volume size limitation and there's a file size limitation. I should know this off the top of my head. I'm drawing a blank at the moment. We have a great article on it. If you shoot me an email, I'll get it to you. I want to say it's like, is it a terabyte or something like that? I don't want to be quoted, but shoot me an email and I'll get you the answer. The answer is yes, there is a file size limitation.
Yeah, you're right. Yep.
Okay, great. And with that, last question. All right.
Yes. So for the S2D, basically the limitation is about 1 petabyte storage. If we just using for the storage, is the cluster set allow us to like expand to like 2 petabyte, 3 petabyte, or 4 petabyte just for the storage?
Your cluster set allowed to span two S2D clusters, sorry.
Yeah. So I think the real question is, hey. S2D today is limited to a petabyte, and could cluster sets be a technique that I could use to get higher levels of scale by kind of concatenating multiple clusters at a petabyte apiece to achieve the high levels of capacity?
Yeah, I mean, in general, I mean, I talked earlier about the compute to storage scale changes that are possible in your fabric, right? This is generally in that category, right? If you want more scale, more storage footprint in your fabric, you basically add an additional S2D cluster as a member cluster in your cluster set. And that snaps into the existing cross-cluster namespace, right? It basically shows up every CSV volume that you create on your new S2D cluster, immediately shows up as a share in the new namespace. You don't need to manage it, it automatically is created for you. The new shares are automatically created for you, it changes with the CSV volumes automatically, dynamically, right? So yes, that's one way for you to scale out your storage while keeping your S2D clusters each self-contained as a member cluster within the same cluster set.
Thank you.
Mm-hmm. And forward-looking, not currently in the preview builds, we are looking at expanding beyond that petabyte. So we're seeing we're seeing many scenarios that, it's kind of interesting, all these new scenarios are kind of popping up, and one of the scenarios that's popped is we have like movie studios who have just really high capacity needs, and so we thought people were just going to put a bunch of VMs on this, and and we designed kind of around that, and we thought a petabyte would be good enough, and then all of a sudden these movie studios are showing up and saying, hey, wow, this is screaming fast. We want to put our movie files on this thing and use it as a NAS device, and all of a sudden we're going, wow, and they have incredible capacity needs, and so we're trying to figure out how we meet those needs, and so that's something we're working on. It's not currently in the insider previews, but it's something down the road. All right, and with that, for like the 10 people that stayed all the way to the end, I will say thank you.
Thank you.
And please fill out a survey. Really would love your feedback, and thank you.
Yep.